Computing mean from grouped data. Direct method. When the scores are grouped into frequency distribution, the individual values lose their identity. These values are represented by the midpoints of the class intervals in which they are located. The midpoints of each class interval is multiplied with its corresponding frequency f. All values of fx, the x are the midpoints, are added to obtain sigma of fx, that is finally divided by the number of observations, that is n. The following formula is used. X bar equals sigma of fx divided by n, where x bar equals mean, f equals frequencies, x equals midpoint of class intervals, n equals number of observations. Example, the table. Computation of mean. X bar equals sigma of fx divided by n equals 10,160 divided by 99, which equals 102.6. Indirect method. The following formula is used in the indirect method for grouped data. X bar equals a plus or minus sigma of fd divided by n, where a equals midpoint of the assumed mean group. The assumed mean group in the example is 90 to 110 with 100 as midpoint. F equals frequency. D equals deviation from the assumed mean group. N equals sigma of fx. X bar equals a plus or minus sigma of fd divided by n equals 100 plus 260 divided by 99 equals 100 plus 2.6, which equals 102.6. Median. It is a positional average. It is expressed using symbol m. Computing median. The data is arranged in ascending or descending order. Median is calculated by using value of n plus 1 by 2th item. Example, calculate the median of the following. Arranging the data in ascending order. Value of n plus 1 divided by 2 equals 7 plus 1 divided by 2 equals 8 by 2 equals the fourth item. Therefore, 8988 is the median. Computing median from grouped data. When the data is in grouped form, it can be computed by using the following formula. M equals L plus I divided by F into N divided by 2 minus C, where M equals median for the grouped data, L equals lower limit of the median class, I equals interval, F equals frequency of the median class, N equals total number of frequencies or number of observations, C equals cumulative frequency of the pre-median class. Example, calculate the median for the following distribution. The median is computed using cumulative frequencies are obtained by adding each normal frequency of the successive interval group. Median number is obtained by n divided by 2, that is 140 divided by 2 equals 70 in the above case. Count into the cumulative frequency distribution from the top towards bottom until the value next greater than n by 2 is reached. In this case, n by 2 is 70, which falls in the class interval of 70 to 80 with cumulative frequency of 81. Thus, the cumulative frequency of the pre-medians class is 37 and actual frequency of the pre-median class is 44. The formula used to calculate the median is m equals L plus I by F into m minus c. M equals 70 plus 10 divided by 44 into 70 minus 37 equals 70 plus 5 divided by 22 into 33, which equals 70 plus 7.5, 77.5 mode. The value that occurs most frequently in a distribution is referred to as mode. The symbol used is Z or mo. Computing mode. While calculating mode, the given data is first arranged in ascending or descending order. Calculate the mode for the following data. Arranging in ascending order. The value of 41 occurring 3 times is the mode. As no other number is in the similar way in the data, this is called unimodal. Calculating mode for the following data. Arranging the data in ascending order. Here, the measures of 54 and 82 both are occurring 2 times in the distribution. Therefore, it is called as bimodal. Similarly, the recurrence of many measures in a series make it multimodal. When there is no measure being repeated in a series, it is designated as without mode. Mean, median and mode. These measures of central tendency can be compared with the help of normal distribution of curve. The normal curve refers to a frequency distribution in which the graph of scores, often called a bell-shaped curve. Most of the observations are on and around the middle value. The extreme values reduce in a symmetrical manner. In the graph, the mean, median and the mode are of the same score. Because a normal distribution is symmetrical, most of the scores occur around the middle of the distribution or the mean. If the data are distorted or skewed in some way, the mean, median and mode will not coincide, and the effect of the skewed data needs to be considered.